Hello everyone, welcome back to my video channel. In this video, I am going to discuss the topic that is structure and biological importance of carbohydrates. Okay, the topic that is structure and biological importance of carbohydrates. So, as we all know, food is the basic necessity of man, right? Because food is the one thing which nourishes the body, and it is a mixture of different nutrients like carbohydrates, proteins, fats, vitamins, and minerals. Okay, these nutrients are essential for growth, development, and maintenance of good health throughout our life, right? And mainly these nutrients are generally divided into two categories, that is macronutrients and micronutrients. See, as you look at in the chart, so food nutrients are mainly divided into two categories, that is macronutrients and micronutrients. Okay, again the macronutrients are divided into carbohydrates, lipids, nothing but fats, and proteins, and micronutrients divided into vitamins and minerals. Again, vitamins are divided into water soluble vitamins and fat soluble vitamins. Here the water soluble vitamins are B and C vitamins, and fat soluble vitamins are A, D, E, and K. Okay, these are fat soluble vitamins. And minerals are again divided into macro minerals and micro minerals. Okay, and this video is about, the topic is structure and biological importance of carbohydrates. So I am going to discuss about carbohydrates. This video is for carbohydrates. Okay, now let's start with the carbohydrates. Now, what are these carbohydrates are then? Carbohydrates, as in the name indicates, carbohydrates, as in the name indicates, it is made up of or composed of carbon, okay, hydrogen and oxygen. These are also called as hydrated carbon. Okay, these are also called as hydrated carbon. Why carbohydrates are called as hydrated carbon? Because here hydrogen and oxygen will be present in the ratio of 2:1, as in the same case of water. Okay, H2O, okay, will be present in the 2:1 ratio. That's why these are called as hydrates of carbon. For example, make you to understand, if you take the example of glucose, okay, glucose, the formula for this is C6H12O6. okay, here if you see, the hydrogen and oxygen is in the ratio of 2:1. okay, these carbohydrates are nothing but, these are very simple. You don't have to think like this is a complicated thing, the biochemistry means it is a difficult thing. No, if you work on the topic, if you sit peacefully and focus on the content, means this topic is very easy. Okay, carbohydrates, these are nothing but sugars. Okay, so daily, the way you are using in your daily life, okay, these are used by us in daily life. Okay, so carbohydrates are nothing but sugars. Okay, or you can say they are polymer of sugars. If we have to define one more way, you can define like this: carbohydrates are organic compounds made up of simple sugars or polymer of sugars that can be hydrolyzed to simple sugar by the action of digestive enzymes. Okay, now coming to the formula, here carbohydrates are hydrates of carbons that obey the general formula. So this is the general formula that obey the general formula, that is CX H2O bracket Y. This is the general formula for the carbohydrates. Okay. For that, for example, if you take the example glucose C6H12O6, you can write like this also, C6H2O bracket 6, because 6 2 ja 12, so again the 12. So this obeys the general formula. Okay, that is CxH2O bracket Y. Okay, and here if you see here the value of X and Y, see the X is 6 and Y is 6. So X is equals to Y, which is equals to 6. Okay, and if we have to take the another carbohydrate, that is sucrose, the sucrose is C12H22O11. Okay, if we have to write in a general formula, C12H2O bracket 11. Okay, if here the X is 12 and Y is 11. Okay, that's why X is not equals to Y, because X is 12, Y is 11. That's why sucrose is not obeying the general formula. Okay, so even though the general formula is applicable for most of the carbohydrates such as glucose, fructose, mannose, galactose, but there are carbohydrates like fucose, like sucrose and ramenose that fail to obey this general formula. That's why to overcome these limitations, okay, the IUPAC, OPAC, okay, OPAC means here it is International Union of Pure and Applied Chemistry, proposed a definition for carbohydrates based on functional groups. Okay, so according to this we can define carbohydrates. According to the OPAC, the definition for carbohydrates is like this: carbohydrates are polyhydroxyaldehydes or polyhydroxyketones and their derivatives. Okay, so let me explain this in more detail. Here the carbohydrates can be defined as polyhydroxyaldehydes or polyhydroxyketones and their derivatives. So here the simple meaning, what is poly? Poly means many. Okay, poly means many. Hydroxy means OH. Hydroxy means OH. Aldehydes. Aldehydes means C double bond O H C. Okay, this is aldehyde. I will repeat one more time: C double bond O C H. This is aldehyde. Here again poly means many, hydroxy means OH, ketones means here the ketone group is C double bond O C and C. Okay, here you can see the difference here. The aldoses will be like this. Here C illi enagutte, C matte H will be present, those will come as a aldoses. Okay, and if you have to find out the carbohydrate, here both this carbonyl group contains carbons, carbon. Okay, here these are ketones. Okay, and aldehydes means H will be like this, you can remember. Okay, this is about the definition of carbohydrates. Okay, now we will see the classification or structure of carbohydrates in more detail. Okay, the structure of carbohydrates, you can see here, coming to structure of carbohydrates. Before that, before explaining this part, let me explain the important part here to make you to understand this definition in a better way. You can take the example of glucose here to find out whether it is a aldose or whether it is a ketose or ketone. Okay, so the formula for the glucose is C6H12O6, right? this is glucose. Okay, so how we can write this one, glucose? So here C6, 1 2 3 4 5 6. Okay, and here the first carbon is carbonyl carbon. Okay, and this is OH, and again this is OH, and then OH, OH, OH. Okay, to compensate, these are H, and again this one is H, again H, 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 H. Okay, C6H12O6. So if you see here, while I am explaining the polyhydroxyaldehydes, here I said, if you see this part, carbonyl carbon, which is attached to carbon and hydrogen. See H here, to the first carbon, this is the first carbon, second, third, fourth, fifth and sixth. Okay, and the first carbon here, if you see, it is attached to H, C, C, double bond O. So that's why this is, that is glucose is, it is a polyhydroxyaldose. Okay, that's how you can find out the whether it is a aldose or ketose. If you take the same example, like example for, you take the example of fructose, okay, which has the same formula, that is C6H12O6. If you write this one, so again 1 2 3 4 5 6 carbon atoms, and but here the second carbon as the carbonyl carbon, and here OH, again this is OH, then OH, 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 and this is H, 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 and again H. Okay, and if you see here, the second, this is the second carbon which contains the carbonyl carbon, and here C, C, double bond O, C, you can see. So this is the ketone group, that is, it is a polyhydroxy ketone. So fructose is a polyhydroxy ketone. Okay, that this is how we can define. So now we will move on to the structure of carbohydrates or classification of carbohydrates. Here the structure of carbohydrates is like this. Carbohydrates can be divided into simple and complex carbohydrates. Simple carbohydrates and complex carbohydrates. In simple carbohydrates, again 3 types, that is monosaccharides, second one disaccharides, third one oligosaccharides. Okay, in actually if you have to study in depth, means oligosaccharides contains the disaccharides. Okay, I will explain the in further. Okay, for the time being, it is divided into monosaccharides, disaccharides and oligosaccharides. The complex carbohydrates into polysaccharides. Okay, again these monosaccharides can be divided into aldoses and ketoses. Okay, and here if you have to know the meaning for the word saccharides, saccharides means sugar. Okay, the meaning of the saccharide is sugar. Here the monosaccharides, if you have to take the examples, you can give the example as fructose, dihydroxyacetone, many examples you can see here. And for example for disaccharides is sucrose, lactose and maltose. Example for oligosaccharide is raffinose. Example for polysaccharide is starch and glycogen. And again, if you see here, aldoses can be divided into trioses, tetroses, pentoses and hexoses, and even it can depend as heptaloses, means which contains the 7 carbon atoms. Okay, and here polysaccharides are divided into homopolysaccharides and homopolysaccharides. Homopolysaccharides, example for that homopolysaccharides is starch and dextrin, and example for heteropolysaccharide is hyaluronic acid. Okay. Here example for trioses is glyceraldehyde. Example for tetrose means erythrose. Example for pentose is ribose, or you can give the one more example, that is xylose, and example for hexose is glucose. Okay, this is the classification or overview how we can classify the carbohydrates. Okay, and in the next we are going to discuss about the first one, that is monosaccharides. Okay, now let us look at what are these monosaccharides. So based on hydrolysis, okay, hydrolysis means breakdown. Okay, based on hydrolysis, the name indicates mono. Mono means single. Okay, saccharides means sugars, means these are simple sugars which consist of one sugar in it, or you can say as IUPAC proposed definition, according to that it is single polyhydroxyaldehydes or ketone. Okay, monohydrates are simple sugars which consist of one sugar in it, or single polyhydroxyaldehydes or ketone units. Okay, and these monosaccharides are simple sugars and which cannot be further hydrolyzed, means they cannot be further broke down into simple forms, because they are simple sugars, they are single units. Okay, they are in single units. Here monosaccharides are colorless, okay, and they are crystalline solids, and these monosaccharides are soluble in water and they are insoluble in non-polar solvents. So as I explained a few minutes back, these monosaccharides are classified into two main classes based on the carbonyl group present in them. They are aldoses and ketoses. Okay, just now I explained what are these aldoses and ketoses are, right? So I explained this one, right? Aldoses and ketoses by taking the example of glucose and fructose. Okay, right? So this is right, this is the aldose and this is the ketose. Here again aldoses, obviously, for example, if you take example for this is glucose, which contains the aldose group, that's why these are called as aldoses, and ketoses contain the ketone group. Okay, and we will move on to the next point here. If you have to take the next point, depending on number of carbon atoms present, aldoses can be further divided into following types, right? The first one is trioses. Tri means 3, okay, so which contains the 3 carbon atoms. For example, for this is glyceraldehyde, okay, dihydroxyacetone is the example. Here glyceraldehyde, so glyceraldehyde which contains the 3 carbon atoms, right? So 3 carbon atoms here you can write like this, that is C, okay, 3 carbon atoms. This is glyceraldehyde, okay, with the 3 carbon atom, and the carbonyl carbon, here the carbonyl carbon is this one, and this is OH, and rest is H, and this is the H. So if you look at this carbonyl carbon, okay, carbonyl carbon, the first carbon contains the carbonyl carbon which is attached to H and C, that's why this is a aldose. Okay, glyceraldehyde is a aldose because the first carbon, okay, the first carbon contains the aldehyde group, that is CHO group. Okay, so the next example which I have taken is dihydroxyacetone. So if you look at the dihydroxyacetone, again this is a 3 carbon atom, because we are giving an example for trioses, right? Okay, these two are the examples. First one glyceraldehyde, second one which I am taking is dihydroxyacetone. So look at whether it is aldose or ketose. So 3 carbon, okay. In the second carbon atom, the carbonyl carbon is present, and this is OH and this is OH, and rest is H. Okay. So the formula for this is C3H6O3. Okay. Here the second carbon, okay, this is the first carbon, second carbon, third carbon. Second carbon, you can see the carbonyl carbon, and you can see here which is attached to C. Okay. So that's why this is a ketose. Okay, this is the ketose. Next one is tetroses. Tetra means 4, okay, which contains the 4 carbons. Example for this is erythrose. The next one is pentoses. Penta means 5, okay, which contains the 5 carbons. That is, example for this is ribose, arabinose, xylose, ribulose. Okay, these are the examples. So like that you can explain so many things. If you have to explain pentose again, I will explain the pentose again. Here the pentose, if you take the example, I can't explain everyone. You should work on everything, keep practicing these things, okay, then only it will become easy. For make you too easy, I will explain the one more example, that is ribose. Here ribose, again this ribose, if you take the ribose, it is example for the pentoses, right? Okay, I am taking explaining the pentoses here. The pentoses, I am taking the example, that is ribose. To find out whether it is aldose or ketose, which is a 5 carbon, right? 1, 2, 3, 4, 5 carbon. Okay, here the carbonyl carbon group is attached to the first carbon. Okay, next rest will be OH, OH, OH and OH, and this is the H here, H and H. So here the aldehyde group, you can see the aldehyde group here, okay, attached to the first carbon, okay, which is attached to the C, is attached to the H and C. That's why it is a aldose. Okay, this is the aldose. Next, the exoses. Exoses means, exo means 6, okay, 6, which contains 6 carbons. Example for this is glucose, galactose and fructose. I explained this. And next is the heptuloses. Heptuloses means, hepto means 7, which contains 7 carbons. Example for this is pseudo heptulose. Okay, and if we have to say the more key points here is that the glucose is the most common transporting sugar in animals, including the humans. Okay, glucose is the most common transporting sugar in animals, including humans. And as I explained just now, that is aldehydes, that is glyceraldehyde and dihydroxyacetone, that is DHA, dihydroxyacetone and glyceraldehyde. These are most common intermediates in carbohydrate metabolism, that is in case of photosynthesis and in case of respiration. These two are the most common intermediates in carbohydrates metabolism. Okay, and the pseudo heptulose, that is heptulose, which okay, example for pseudo heptulose is example for the heptulose. Okay, so this pseudo heptulose is only this is only the naturally occurring heptulose that participates in carbohydrate metabolism. Okay, and the fructose, okay, the fructose, fructose is the sweetest naturally occurring sugar. Okay, this is the sweetest naturally occurring sugar. If you have to measure in a sugar scale, means the fructose is 180. Okay, it measures about 180 and good. Okay, these are the some of the key points on the monosaccharides, and in the next video I am going to discuss the other classification, that is oligosaccharides and polysaccharides. I hope this video is helpful for you all, and if you learn something new from this video, please do subscribe and share. Thank you everyone.